Hey guys, welcome to lesson 114, day 2. Today our goal is going to be to find points of intersection between two functions, and we want to talk about that with multiple representations. So we're going to do it with a graph, we're going to do it with a table, and we're also going to do it with the equations. Okay, so we're going to use our calculator to help us do all of this. Well, most of it. All right. Now, when we're doing this, remember what we're finding is the point of intersection. So if I have two functions or two graphs, right, I'm finding where they meet on a graph. So when we set those two equal to each other, that's when we know that they share a point or they share an intersection. All right, so the first thing we're going to do is go to our calculator. So make sure you have those. Turn that thing on. And you're going to hit y equals. Okay, this is where you type in your functions. So in y1, you type in your first function, as I already have here. And then in y2, you type in your second function, as I also already have. Okay, so if you're following along, this would be a good time to pause, grab your calculator, and type those equations in. Okay, and I've also put all the step-by-step directions that I'm about to tell you here as well. So if you miss something I say, you can refer to those directions. Okay, once I type these in, we can go ahead and hit graph. And it's going to give us this exact picture. Well, not this yet, but we're working towards it. Alright, so I have my blue parabola and I have my red parabola. Now, we're looking for intersection points, and the thing is, we can't really see where those are too well, right? They're a little out of our viewing window. So what we want to do is go ahead and hit the zoom button, okay? And this will allow us to move around on the graph and get a closer look. So I'm going to go ahead and hit zoom out. Okay, if I hit zoom out, it'll show us more values. I'll hit enter. And you'll notice there's a little cursor here. We're going to go ahead and move that up. Yeah, I have to press this button a good amount of times. We want to move it up to kind of be by the blue parabola, and that way it'll zoom out at that section of the graph. It's taking its sweet time. There we go. It's gone a little faster now. It's much less annoying to do on a real calculator, but we're making do here. Alright. My advice is to get it to be above your blue parabola, if you can. Give the patience. Alright, here we go. Hit enter. And there we have a picture forming. It's going to look a lot like the one you see here. Alright, so now we have our picture. And with this picture, we're going to use it to find our intersection points. Now the thing is, it's not super easy to see where those points are in this zoomed out view. So we're going to follow some more directions, and again, I've written them here as well. Our graph actually is a tool that will help us pinpoint the intersection, or our calculator will do it for us. So you're going to go ahead and press this second button and then trace. Okay, we're going for that calc function. We're going to scroll down to where it says intersect. Press enter. And now it's going to say first curve. We just want to move our cursor to be by one of the intersections, okay, just to get close to it. We're going to find the one on the left first. Press enter. Second curve, we just want it, again, to be close to the intersection. You'll notice now it's on my red parabola. That's close enough, so press enter, and then press enter again. So you'll see that we have one intersection at -2, 24. So I'm going to go ahead and write down that one of my intersections are at -2. Actually, I guess here, -2, 24. Okay, and then we have another one, so we're going to go ahead and repeat that process. Let's pull this back up. Okay, so now we can go ahead and go back to that menu, so second, trace, hit intersect again, and this time we're going to move our cursor to be closer to the other intersection, so our calculator knows that we're looking for this one. Press enter. This one is close enough to where we want it to be, so we'll press enter again. And press enter again. We find that our intersection is at 3, 9. So on my points here, I will write 3, 9. Okay, and that is how you find intersections using your calculator. Okay, if you just remember those steps, your calculator can do most of the work for you. I would advise you to make sure you have access to these somewhere so that if you have to do this on a quiz or something, you have easy access in case you forget how to do it. Okay. And also keep in mind those are these points right over here that we found. Alright, so the next thing we're going to do is figure out how to do this with a table. So keep in mind that the table is really handy to find intersection points, but only if the numbers are nice. Okay, the table is probably not going to show the intersection point if it's a decimal or something messy, and that does happen frequently. So we won't always be lucky enough to use a table, but it's a good function to be able to have and to use. So again, I put instructions here. What you would do is go ahead and again go to y equals. We start the same way. Put the first function f into y1, put g into y2, and then instead of hitting graph, you're going to go to table. Okay, you'll see it's written right above graph. So we hit second, press graph, and it makes our table appear. Okay, look, it's the same one that's right over here. And what we're trying to find is intersection points. So if you're looking for a point of intersection, you're thinking, okay, where are these graphs the same? Right? This is the output for the first function, this blue one, and then this is the output for the second function. So if we look at our options here, we'll see that here at x equals -2, both of our functions have an output of 24. Okay, and so that tells us, just like we found here, that one of our intersection points is at -2, 24. And then if we continue to scroll down, at 3, we have another match. And that tells us that we have an intersection point at 3, 9. And that's the same thing we figured out up here. So that's how you can find intersection points with tables. Okay, you just have to find out where the numbers match in both of your y columns. Alright, so now that we've talked about how to find intersection points on graphs and on tables, we have one last method, and that's going to be using the equations. You'll probably find that to be the more tedious method, but sometimes it's really necessary, and it's also often the most accurate. So, when we are trying to find the intersection point with solutions, remember we're looking for the spot where both of the graphs or both of the equations are equal. So the first thing we want to do is set these two equations equal to each other. So we're going to say 2x squared minus 5x plus 6 is equal to -2x squared minus x plus 30. Okay, so our goal is ultimately going to be to solve this equation, but first we have to do some work. Right? Recall yesterday we used the quadratic formula to solve equations that looked like these, but they were always equal to 0. Okay, so our goal first, before we can use the quadratic formula, is to get this to equal 0. In order to do that, we have to move everything on the right side to the left. So we have to use opposite operations, right? We're going to have to add 2x squared to both sides. Make sure you add them to the proper term that they match with. Sorry, my lines are kind of terrible. So this gives us 4x squared minus 5x. The rest of them didn't change, just that 4x. Okay, these go away on this side, so we're left with negative x plus 30. All right, next we're going to move the x, so we got to add it to both sides. That's going to combine with the other x term. All right, so now we have 4x squared, negative 5x plus 1x is negative 4x plus 6 equals, these go away, 30. Sorry. All right, and then lastly, we gotta move that 30 away as well. So we'll subtract it from both sides. So finally, we have a quadratic equation that's equal to 0. Now we can use our quadratic formula, which I'll just put over here. Okay, so we're ready to go ahead and start that same process that we did yesterday. So identify A, B, and C. A is going to be 4. B is going to be negative 4. And C is going to be negative 24. All right, so now let's go ahead and start plugging into our formula. We have negative b plus or minus the square root of b squared, so we put our b in that spot, minus 4 times a, our a value is 4, times c, which is negative 24, all over 2 times our a value. Okay, now remember, once we get to this point, this is where we start simplifying things as much as we can to make our own lives easier. So negative times a negative, that's just going to give me a positive 4. And now we can start to simplify things in the square root. Negative 4 squared is 16. That one's easy. This one you might need to bust out your calculator for. Negative 4 times 4 times negative 24. Okay, 384 plus 384 all over 8. 4 times 2 is 8. Okay, now we can keep simplifying. We know that 16 plus 384 is 400. Okay, and then finally, we can take the square root of 400, and that's going to equal 20. So now we're ready to branch off into our two solutions, right? One of them will be using the plus. One of them will be using the minus. So this one gets us 24 over 8, which is 3. This one, it's ugly, okay. This one gets us negative 16 over 8, which is going to be negative 2. All right, so when we get to that point, we know now that our points of intersection are going to be 3 comma something and negative 2 comma something. Now, from our last page, we already knew that our intersection points are at negative 2, 24, and 3, 9. So we're not going to take the time to find those. But if we needed to, if we didn't already know this, all you need to do is plug your x value back into either one of these equations, right? And then you'll get the output, or the y value. All right. And that is how you would find intersection points with equations. Again, I know that's really tedious, but sometimes this really is the best way. And that is all for today.